So let's talk about masters and the Kubernetes control plane. So a Kubernetes cluster is effectively a bunch of masters and nodes. Well, we need something to run these on, and we have said already that Kubernetes is pretty platform agnostic. So it runs on Linux, but it's just not opinionated on whether underneath that it's bare metal, VMs, cloud instances, OpenStack, etc. It's just not bothered. Give it Linux and it will run. A master is actually a bunch of moving parts, and in the simplest and the most common setups, they all run on a single server. Now, this is not a standard, no doubt it will change in the future. I mean, multi-master HA is already a thing. It's a bit complex to configure right now, but yeah, it's totally doable. We generally consider it best practice to keep the master free of user workloads. So run your apps on the nodes and keep the master free for looking after the cluster. It just keeps things clean and simple. Now, if we drill down a bit, we need to know about the API server. Now you need to pay attention. It's our front end into the master or the control plane. In fact, it's the only master component that we should be talking to. For example, it's the only one with a proper external facing interface. Like all good things these days, it exposes a RESTful API and it consumes JSON. Now, how that looks in the real world is we send it our manifest files, which we mentioned already. These declare the state of our app like a record of intent. The master validates it and it attempts to deploy it on the cluster. Then there's the cluster store. Now, if the API serves as the brains of the cluster, then the store is definitely its memory. So the config and the state of the cluster gets persistently stored in here. Right now, it's etcd. Yes, there's been talk like forever about there being other options, but right now etcd is where it's at. What's etcd, you ask? So etcd is an open source distributed key value store. It's developed by the guys at CoreOS. It's basically a NoSQL database, but it's distributed, consistent, and watchable. And when I say consistent, I mean yes, all the copies can talk to each other and they work out consistency. Kubernetes uses etcd as the source of truth for the cluster. No etcd or cluster store, no cluster. So make sure you protect this store and you've got a solid backup plan for it. Alright, so what else have we got under here? Yes, the controller manager. This is a bit like a controller of controllers, if you will. We have got a bunch of controllers: node controller, endpoint controller, namespace controller. There's practically a controller for everything. And these guys all sit in a loop and they watch for changes. The aim of the game being to make sure that the current state of the cluster matches our desired state. But like we said, right now they are all managed by the controller manager. Okay, we have also got the scheduler. It watches for new pods and it assigns them to workers. And yes, that's the high level. But it's doing it a huge disservice because it's got a ton of things to think about. So things like affinity and anti-affinity, constraints, resource management, etc. There's loads more, but I think that's probably enough for now. Now, because the API server is our front end into the master, and it's the only component in the master that we really deal with directly, sometimes we fall into just calling this the master. So when we say things like maybe issue commands to the master, we actually mean issue commands to the API server. We just mix and match the master and the API server quite a lot in our lingo. I think the important thing to remember though is no other master components expose an endpoint for us, just the API server, and by default that does it on port 443. So the master is the brains of Kubernetes. Commands and queries come into the API server component of the master, and we can stick authentication on at this point. That's beyond the scope of this course, though. We have not covered this yet, but commands come in usually via the kubectl command line utility, but they are formatted as JSON. Then there's a bit of handshake that goes on between all these components here, and depending on what's going on, commands and action items make their way to nodes over here. Speaking of which, let's talk about nodes in the next lecture.